The universe is a place of breathtaking beauty. We live on a small rocky planet orbiting an average star in the Milky Way. When we look up at the night sky, we see only a tiny fraction of what is out there. The cosmos stretches far beyond our comprehension, holding countless stars, galaxies, and perhaps even forms of life we cannot yet imagine. This vastness can inspire awe and spark apprehension about the unknown forces at play. Exploring space reveals many wonders and startling discoveries. The more we learn, the more we realize how much we do not know. Some cosmic discoveries can seem unsettling, reminding us of the dynamic and sometimes violent nature of the universe. Understanding these phenomena helps us appreciate our place within this grand cosmic tapestry. It encourages us to continue our exploration with curiosity and respect for the universe's power. The sheer scale of cosmic events is difficult to grasp. Phenomena that unfold over millions or billions of years shape the universe. Forces that dwarf anything experienced on Earth are constantly at work. When we talk about terrifying things in space, we refer to these immense energies and scales. It is about recognizing the powerful processes that shape the cosmos. This understanding helps us put our existence into a larger perspective, fostering a sense of humility. Our journey to understand the universe is just beginning. Each new telescope and space mission peels back another layer of mystery. Sometimes what we find challenges our previous notions and forces us to think in new ways. The terrifying aspects are often just the parts we understand the least. As our knowledge grows, apprehension can transform into fascination. The universe is not actively trying to be scary, it simply is. One of the most dramatic events in the universe is a galactic collision. You might imagine this as a chaotic crash, but the reality is quite different. Galaxies are mostly empty space, so direct star-on-star collisions are rare. It is a slow gravitational dance. These galactic invaders are simply other galaxies drawn together by gravity. Over immense timescales, they approach each other, and their outer regions begin to intermingle. Gas clouds within each galaxy are compressed, triggering bursts of new star formation. A galactic collision can be a period of renewal, creating millions of fresh young stars. Our Milky Way is on a collision course with the Andromeda galaxy, predicted to begin in about 4.5 billion years. When Andromeda and the Milky Way merge, they will form a new, larger elliptical galaxy, often nicknamed Milkomeda. The primary effects are gravitational, altering the structure of both galaxies. Stars will be flung into new orbits, and some may be ejected into intergalactic space. The central supermassive black holes of each galaxy will eventually merge, releasing tremendous energy in the form of gravitational waves. It is a transformation, a cosmic metamorphosis, rather than outright annihilation. These events shape the very fabric of the universe. They remind us of the dynamic and ever-changing nature of the cosmos. Understanding these processes helps us appreciate the grand scale of cosmic evolution. When we delve deeper into the mechanics of galactic collisions, we find a fascinating interplay of forces. Gravity is the primary conductor of this cosmic ballet. As two galaxies approach, their mutual gravitational attraction distorts their shapes, creating tidal tails. These beautiful sweeping arcs are a hallmark of interacting galaxies. Gas clouds within the colliding galaxies collide, compress, and heat up, triggering bursts of star formation. Regions that were once quiescent clouds of cold gas can suddenly ignite with the light of thousands of newborn stars. The supermassive black holes at the centers of most large galaxies also participate in this grand dance. As their host galaxies merge, these behemoths begin a slow spiral towards each other, radiating enormous amounts of energy in the form of gravitational waves. The eventual merger of these supermassive black holes is one of the most energetic events in the universe. Ultimately, the two galaxies will settle into a new, combined structure, often resulting in a larger, more spheroidal galaxy known as an elliptical galaxy. This entire process showcases the power of gravity to sculpt and reshape the largest structures in the cosmos over eons. It's a fundamental aspect of galaxy evolution. Beyond the grand scale of galactic collisions, the universe presents us with fleeting, powerful mysteries. One such enigma is the fast radio burst, or FRB. These are incredibly intense but very short blasts of radio waves, typically lasting only a few milliseconds. In that brief moment, they can release as much energy as the sun does in an entire day. Their origin is one of the most hotly debated topics in modern astrophysics. They appear to come from distant galaxies, far beyond our own Milky Way. Some FRBs are one-off events, while others are repeaters, flashing multiple times from the same spot in the sky. This distinction provides crucial clues about their origins. A leading theory involves magnetars, a type of neutron star with incredibly powerful magnetic fields. Sudden reconfigurations or starquakes on the surface of a magnetar could release the enormous energy seen in FRBs. While FRBs pose no direct danger to Earth, their sheer power is humbling. Studying them helps us probe the conditions in distant galaxies and understand the behavior of matter under extreme conditions. Another type of strange flash that commands our attention is the gamma-ray burst, or GRB. These are the most powerful explosions in the universe since the Big Bang. When a GRB erupts, it can outshine its entire host galaxy in gamma rays for a few seconds to a few minutes. The energy released is equivalent to converting the entire mass of the Sun into pure energy in an instant. GRBs come in two main varieties, short duration and long duration. Short GRBs are thought to be produced by the merger of two compact objects, such as neutron stars or a neutron star and a black hole. Long GRBs are generally associated with the death of very massive stars in an event called a hypernova or collapsar. The potential danger from a GRB, though remote, is significant. If a GRB were to occur within our Milky Way, and its narrow beam of radiation was pointed at Earth, the consequences could be severe. The intense burst of gamma rays could strip away our planet's ozone layer, exposing life to harmful ultraviolet radiation. Fortunately, GRBs are rare events, and the chances of one occurring close enough and aimed directly at us are very small. They act as cosmic lighthouses, allowing us to probe the early universe and study the life cycles of massive stars and the formation of black holes. Closer to home, within our own cosmic neighborhood, other potential dangers exist. Asteroid impacts are a well-known example. We have clear evidence that large asteroids have struck Earth in the past, with significant consequences. The most famous is the impact event about 66 million years ago, believed to have contributed to the extinction of the dinosaurs. Fortunately, astronomers are actively searching for and tracking near-Earth objects. Through projects like NASA's Planetary Defense Coordination Office, we are getting better at identifying potentially hazardous objects. The goal is to find them well in advance of any potential impact, giving us time to develop and implement mitigation strategies. Another local hazard comes from supernovae, the explosive death of a star. If a massive star were to go supernova relatively close to our solar system, the blast of radiation could be harmful. While no known stars this close are expected to go supernova soon, it is a reminder that even stellar life cycles can have implications for planetary habitability. These local cosmic perils underscore the fact that our solar system is part of a dynamic galaxy. Studying these phenomena helps us understand potential risks and provides valuable insights into the formation and evolution of planetary systems. The universe presents us with phenomena that can seem terrifying because they are so powerful and often poorly understood. From the slow dance of colliding galaxies to the sudden flashes of fast radio bursts and gamma-ray bursts, these cosmic events speak to the immense energies and scales that govern the cosmos. This reality is not meant to instill constant fear, but rather a profound sense of awe. Our knowledge of space is still incredibly limited. Each new discovery often brings new questions. The terrifying aspects are often simply frontiers of our understanding. As we learn more, what once seemed menacing can become a fascinating puzzle. The study of these powerful cosmic events pushes the boundaries of science and technology. The quest to understand the universe is a deeply human endeavor, driven by our innate curiosity. The challenges are immense, but the potential rewards are immeasurable. As we contemplate the formidable aspects of the cosmos, let us do so with an appreciation for the universe's complexity and dynamism. Thank you for joining me on this brief exploration of some of the universe's most powerful and intriguing phenomena. May our curiosity continue to guide us as we reach for the stars.